Welcome to the 11th edition of Climate Change.
In Norway, a major shift in global shipping is taking shape with the launch of the world's first hydrogen-powered cargo ship, capable of running entirely on hydrogen fuel and emitting only water vapor. Using fuel cells that combine hydrogen and oxygen to generate electricity, the vessel offers a zero-emission alternative to one of the most carbon-intensive industries, while also reducing noise pollution in marine ecosystems.
Cities are rethinking how waste is managed at scale. In Sweden, underground pneumatic vacuum waste systems are eliminating the need for traditional garbage collection, transporting waste through sealed pipes using air pressure, reducing emissions, odor and manual handling, and thus improving urban hygiene and efficiency.
The energy transition is progressing in more incremental but practical ways. In Japan, Kawasaki Heavy Industries has launched the world's first commercial gas engine capable of operating on up to 30% hydrogen mixed with natural gas, allowing existing infrastructure to reduce emissions without requiring complete replacement. These systems can be retrofitted into existing power plants, offering a more realistic pathway for industries transitioning away from fossil fuels. Parallel efforts are underway to build hydrogen supply chains, including large-scale liquefied hydrogen terminals and shipping systems, highlighting how the transition is as much about infrastructure as it is about technology.
While such systems point toward a cleaner future, scientists warn that the planet itself may be moving toward irreversible thresholds. A growing body of research highlights the risk of a hothouse Earth trajectory, where warming triggers self-reinforcing feedback loops, melting ice reduces reflectivity, thawing permafrost releases stored carbon, and dying forests lose their ability to absorb emissions. With global warming now occurring at 0.3 degrees per decade, 6 times faster than mid-20th century rates, and atmospheric carbon dioxide levels hitting 420 ppm, scientists caution that crossing interconnected tipping points could lock the planet into long-term warming even if emissions are reduced.
Nature continues to demonstrate how deeply interconnected climate systems are. Marine ecosystems rely on processes that are often invisible but critical. Whales play a key role in regulating climate through what scientists call the whale pump, where nutrient-rich waste released near the ocean surface supports phytoplankton growth. These microscopic organisms absorb carbon dioxide and produce oxygen, forming the base of the marine food chain while helping regulate atmospheric carbon levels. Declining whale populations, therefore, do not just impact biodiversity, they weaken one of the ocean's natural climate regulation systems.
This complexity is also evident in solutions often seen as simple. Tree planting is widely promoted as a climate fix, but scientists emphasize that its impact depends heavily on location, scale, and long-term survival. While forests absorb carbon, there is limited land available, and planting trees cannot offset emissions from fossil fuels at current levels. In some regions, such as snow-covered areas, trees can even absorb more heat due to reduced surface reflectivity. Experts stress that protecting existing forests and reducing emissions remain far more effective than relying solely on reforestation.
Climate change is also reshaping ecosystems in ways that are already visible. A long-term experiment in the Rocky Mountains, where scientists artificially increased temperatures by 2 degrees, showed that grasslands did not flourish as expected. Instead, shrubs expanded 1.5 times, soil moisture declined by up to 20%, and several plant species disappeared. This process, known as shrubification, is now being observed globally, including in Arctic regions where shrub cover has increased by 2.2% per decade, signaling a shift in entire ecosystems as warming removes natural growth constraints.
We will return next week with more updates.